Welcome to Text Education. We are still looking at enzymes, and now our main focus is going to be on the effect of temperature on the rate of enzyme activity. If we can take a question and we ask ourselves from this data, we have plotted the rate of enzyme activity against temperature. Of course, biologically, on our x-axis and on our y-axis, a factor that affects a physiological process is always represented on the x-axis, and a factor that an outcome of a physiological process is always on the y-axis. So meaning, for a line graph, whatever goes on the x-axis should be a continuous variable, yet these are not continuous, as we can see in such regions. So if we can take a question and we say, describe the effect of temperature on the rate of the reaction, or we can say on the rate of the enzymatic activity. How do we answer this? Our answer would be, if you observe this graph, this is true biological data. So what can we say? It is showing us that temperature is increasing from the origin here, which we don't know whether it is a zero or what, but as it takes the course that side, temperature is increasing. In this region here, we can still see temperature is increasing. So the x-axis is increasing. How is it affecting the y-axis? So we would say this is low temperature. So we would say 1. Lower temperatures cause a low rate of enzyme activity. That would be one description we are taking. Lower temperature causes a low rate of enzyme activity. That's when we are describing the effect. Then we continue, report this. Increase in temperature causes increase in the rate of the enzyme activity at lower temperatures. What have we reported here? We have reported this, that at relatively lower temperatures, increase in temperature causes increase in the rate of the reaction. How shall we report this? We can say moderate temperatures cause the rate of the enzyme activity to remain almost constant. we cannot say that one is constant biologically. It is almost constant. If we had values here, we would quote them and say what they do. We shall see in subsequent examples how we can quote if the values are there. Then we are reporting now this. At higher temperatures, increase in temperature causes a decrease in the rate of the enzyme activity. But biological graphs, one thing is, whichever statement you put forward from a graph from data analysis has to be with a biological background. So our question, if that is question A, our question B, I would say, explain the effect. Explain the effect in A above. How do we go about that? We have got statements that we can explain. So our explanation, let's put it here. The explanation is coming from the data as it was on the graph, but from your descriptions. From your descriptions. So we'll continue and say explanation. Explanation. So we'll say lower temperature causes a low rate of enzyme activity. That must be with the biological background to explain. So we put on a because here. Because at low temperatures, fewer enzymes gain enough kinetic energy to catalyze, even if I ended there. So fewer enzymes get such kinetic energy, which is just enough to continue catalysis. We can also say even fewer substrates have that enough kinetic energy, but let's keep it to enzymes. That is for this. This one is saying increase in temperature causes increase in the rate of enzyme activity. We don't fear to repeat ourselves, because you cannot explain minus putting forward an assertion. At lower temperatures, even we can put to a maximum. At lower temperatures, we put our because. Why? Because increasing temperature supplies more heat to activate more enzymes for catalysis. More enzymes, more heat, more enzymes. Those qualifiers are very, very crucial. More heat, more enzymes. We get that. Then we have another one. Moderate temperatures. Moderate temperatures cause the rate of the enzyme activity to remain constant. Said almost constant. Our because here, what is the reason? Because at such temperatures, all enzymes present are all active, actively catalyzing. Are all actively catalyzing. So it would mean that all enzymes that are present within the reaction mixture, that temperature is enough to activate all of them. What about the last one? What about the last one? You can say, what was it saying? At higher temperatures, increase in temperature causes a decrease in the rate of the enzyme activity because such temperatures supply more heat that now starts denaturing some enzymes, because we know they are a protein in what? In nature. And denaturation is distortion of the functional structure of a protein. So we would have known now the effect of temperature on enzyme activity. It causes activation, but also at the same time temperature causes denaturation of enzymes if it becomes high. So all in all, enzymes work best at certain optimum temperatures. And what are those temperatures? Around 37 to 40, enzymes will still be actively catalyzing. Beyond 40 degrees Celsius, enzymes some of them become denatured. If the temperatures continue to increase, enzymes will become denatured fully. Physiological processes within our bodies will stop, and that's the cause of death when you have very high fevers, because the enzymes stop working and there is no single physiological process within our bodies that continues without two enzymes. So thank you for listening. When we meet again in our subsequent sessions, look out for the effect of pH and other factors that affect enzyme controlled reactions.